Hello, welcome to Tech Transform. Today we are going to discuss about one of the another open source libraries based upon Python programming language, that is Panda. So Python Panda is a high level data structure and manipulation tool designed to make data analysis and data manipulation very fast and easy way in Python. It's built on top of NumPy and makes it easy to use in NumPy centric application. It's very flexible in handling of missing data. It comes with an labeled access and supporting automatic or explicit data alignment. The same data structures can handle both time series data and non-time series data. It can do arithmetic operations and reductions like summing across an axis would pass on the metadata access levels. Merge and other relationship operations found in popular databases like SQL based, for example, can do all of these things in one place. So it's a pretty very powerful. So let's see about the introduction to pandas data structures. To get started with the pandas, we need to understand with its two workhorse data structures. The main two concepts in pandas are series and data frame. Series and data frame you can correlate with your SQL table or Excel, like a spreadsheet structure in your Excel worksheet. If in your Excel, if let's say only one column, you can correlate, this is called a series, and data frame is nothing but a whole in a combination of rows and columns, more than one columns in a table. So data frame is related to table and series related to one column in an Excel sheet. So in this video I'm going to cover only series, and in the next part of this particular series of session I'm going to cover data frame. So let's get started with the series. What is series? A series is a one-dimensional array-like object containing of an array of data and an associated array of data labels called its index. Means it will contain array of array-like object. It will contain different values, and along with that it will give you the index position also. So let's get started with the hands-on. The very first thing we are going to do, that let's say obj is equal to before that we have to import all those packages and everything. For to install panda, we can type pip install pandas. So pandas package will install in your machine by using this command. I'm not running it because it's already installed in my machine. In order to work with pandas, and as I already told you, it's built on top of NumPy, so we have to import NumPy pandas both in our when we want to work with this. We want to import these two packages. First is import NumPy as np, import pandas as pd, from pandas import. We are going to work with these two, series, data frame. In this session I'm just going to cover only series, but still I am importing both of these two, so you will have an idea how to work with that. So we now the package import and everything is done. Let's get started with the hands-on. obj, let's just watch how I am creating a series data. So this is series. Here you can pass list. I am giving value 1 3 4 6 7 9. Okay, this is what we have. This list is going to convert into series object, and now try to print obj. You got, this is not a normal type in Python. This is a special type. You can check with also with the type variable obj. So this is type is pandas.core.series.series. You can see we got as a 0th index. We are getting values and also we are getting index value. So you can do obj dot values to get all values, obj dot index to get all the index. So start from 0, stop at 4. Now let's say you want to change the index. This is the by default index. If you're not going to assign anything, it will change your by default it is going to take 0 up to integer index. Let's say I want to change the index. For that I can do obj1 is equal to series of 1 comma 3 comma 5 comma 7. Then I can specify index also. A, B, we have 4 elements, so we are going to give 4 indexes. Okay, now print obj1. See, our index got changed. Initially it was 0 1 2 3, now it is A B C D. We can access also obj1. Let's say I want to access this 7, then I will provide index t. We can do filter. We can apply filter also. Let's say this contains 1 3 5 7. I want the values which is greater than 3. So I can write inline condition like obj1 greater than 3. We got that 5 and 7. We can apply a lot of filter here. Okay. Now let's try to do simple case study using series. I'm going to take one dictionary object s data is equal to, I'm going to use couple of cities name here. Let's copy this so we can create it faster. Okay, just watch, I'm trying to create a dictionary here with, let's say, Ohio, Oregon, Texas, Utah. So these are the state name, and I'm giving the population something like 3,000, 5,000, 6,700, 67,000, Utah 8,000. So this is nothing, this is just our normal dictionary. Now we want to convert, because this also containing similar, like this also exhibits similar type of structure, index and value. So we can convert this dictionary into series object. For that, obj3 is equal to series is data. Now let's print obj3. See, we got that index is now index this key text index position Ohio, Oregon, Texas, Utah. Okay, now let's change this index. We can change this index from another list variable. Let's say I have states, a list of states. I'm calling California. Okay, Texas, Ohio, Oregon. So these are the states. Now we want to create another object using this s data, and having this states as an index. How we can create that? obj4 is equal to, we are going to convert into series. Then we have to pass the s data. Then another parameter we can specify, index is equal to states. But you can see in our s data, California is not present, Texas, Ohio, Oregon is there, and one more extra, Utah is there. But our states containing all these things. See, let's see how it is going to behave. obj4, printing obj4. Now see, because it is not able to find this index value, this index data here in the dictionary, that's why it's giving you nan. Nan means not a value, because it didn't find anything. Texas is fine, it will match all those indexes what you're giving explicitly. It will try to match and give you all those column values here. And see here, California, Texas, Ohio, Oregon, these indexes it could able to find the match, but here it is not able to find the match. It's give you nan. Now we have obj3, obj4. Now let's try to add this obj3 plus obj4, obj3 plus obj4. Let's see what happens. In obj3, Ohio is there. In obj4, in obj3, Utah is there. California is not there. In obj4, California is there. Utah is not there. See how it's going to handle obj3. It will give you all the indexes. It's available in both the objects, but it's California because it's not present in both the things. So nan. Utah is present in one, but it is not present in the second object, so it's giving you nan. And also, if you want to give this particular obj, this object a name, you can specify like obj4 dot name. Let's say I want to give as a population. Now if you try to print obj4, you got this name population. Okay. If you want to change this, if you want to specify what are these index columns, if you want to specify, for that obj4 dot index dot name is equal to states. Now again print obj4. See, this is coming obj4. So that's like that's all with this series, Panda series. Series nothing, you can treat it as a single column in a Excel, and these are the indexes for that particular, for all the rows you are seeing. N rows, single column. So this is series. In my later video, I'm going to come with a data frame. That is nothing that is similar to table, means, and in Excel you have more than one columns and rows. So that's all for this video. Thanks for watching. Have a good day. Bye.